In this lesson, we are going to work on absolute maximum minimum of a continuous function on a closed interval. C and f of c is called a critical point on the graph of a function if either f prime of c is 0 or f prime of c does not exist. By looking at the graph of a continuous function on a closed interval, we'll see a function attains its global maximum minimum either at a critical number or at endpoints. A and B are called endpoints of the interval. Maximum, absolute maximum, where derivative is 0. Absolute minimum, when derivative does not exist. Absolute maximum at endpoint, at the beginning. Absolute maximum at the endpoint, at the end. You can verify the statement by looking at the graph of different functions. Let's find global or absolute maximum minimum of y equals x2 minus 2x on closed interval 0 and 3. To do this, we find the derivative. Derivative always exists. We set it to 0. We find a critical number. The only critical point on the graph of the function is 1 and negative 1. The value of function at 0 is 0, at 1 is negative 1, at 3 is 3. Therefore, local maximum is 3 and 3 at one endpoint, and local minimum is 1 and negative 1 at critical point. By looking at the graph of the function on the given interval, we can verify 1 and negative 1 is the minimum, and 3 and 3 is absolute maximum. Let's look at another example. F of x equals absolute value of x minus 2 when x is between negative 1 and 3. We know this function is not differentiable at 2. F prime of 2 does not exist. And that is the only critical number on the graph of the function. 2 and 0 is the critical point. The value of the function at endpoints are 3 and 1. At negative 1 it is 3, at 3 is 1. Therefore, local maximum occurs at endpoint, negative 1 and 3 on the left side. And local minimum occurs at the critical point, 2 and 0. Thanks for watching.